A very good day to my dear lecturer. Today we are from Group A. Today we are going to present regarding the topic of rolling water bottles, investigating the effect of water volume on distance rolled. We are from Group A, and this is our team. Nikishore Analaki Sarandan, Mukesh Analaki Prakash, Nelson Analaki Nyanandas, and myself, Roshan Kumar Nair Analaki Nayakumar. Now I'm going to present regarding the executive summary of this project. This project explores the effect of different water volumes on the rolling distance of a plastic bottle. Bottles were filled from 50 ml to 500 ml in 50 ml increments and rolled on a smooth, tiled floor. Distances are measured in centimeters and analyzed using the simple linear regression. This experiment showed a clear trend: more water leads to shorter rolling distance. This project allowed us to apply real-world physics behavior to statistical tools and develop skills in data analysis, graphics, and teamwork.
Good morning, everyone. Today, my team I will be presenting a project about rolling object, something we often see in daily life, but don't really think much about the factors affecting their movement. For our investigation, we focus on how the water of the amount of the water in the bottle influence its rolling behavior. Our main question is: does the water volume influence how far the bottle rolls? Based on our understanding, our hypothesis is that a bottle with less water will roll farther. This is because with less water, there's lower friction and less inertia, allowing the bottle to travel a greater distance. And the objective of projects are to apply what we learn in class to real world situation, collect and analyze data during basic statistical rules, understand concepts like slope and intercept through regression, and lastly, to develop our teamwork and problem solving skills while conducting this experiment. Next, let's move on to our filler table summary, which organizes the key points of our investigation. Starting with the facts, we observe the bottle roll differently depending on how much water is inside them, and the distance roll on can be measured accurately. We made sure to use the same bottle and the same setup throughout to maintain fairness in our testing, and we collected 10 data points to have a good enough sample for analysis. For these facts, we developed several ideas. For example, the heavier bottles might be experience more friction and inertia, reducing their rolling distance. Also, that adding mass likely shortens the distance the bottle travels. However, along the way, we identify some learning issues such as how exactly weight affect the rolling behavior, which statistical tools are appropriate for analyzing our data, how to minimize the bias in our experiment, and in what slope and the intercept mean in the context of our regression analysis. Finally, for our action plan, we refer to physics and statistics resources to deepen our understanding. We use Excel and regression analysis to analyze our data, carefully control and our variables to reduce bias, and use the trendline equation to intercept our results. This schematic approach helps us to stay organized and draw meaningful conclusions for our experiment.
Well, we are going to discuss the methodology for this experiment. The materials are used are one plastic bottle, a measuring tape, smooth tiled surface, camera or a stopwatch. The steps taken are: fill a bottle in increments for 50 from 50 ml to 500 ml. Push the bottle from the same start line with consistent force. Measure the distance in travel in centimeters. The control factors are same bottle type, floor, and environment, same person pushing each time, and the same direction and starting line. This setup ensures fair comparison between all trials.
So this is the data collected for the project.
So the water volume increased 50 ml for every round until it reached the 500 ml. So as the water volume increased, rolling distance of the water bottle consistently decreased. So this is the water volume was distant roll graph that we get from the data collected. Scatter plots was drawn to show the trend between water volume and rolling distance. A linear regression line was added with this equation. Distance equal to negative 0.1833 times volume plus 139.6. For interpretation, slope is equal to negative 0.1833. Every 1 ml of water reduces rolling distance by 0.18 cm. For intercept, 139.6 cm. Theoretical distance if there were no water. This shows a negative linear relationship between mass and rolling distance.
Well, we have reached to the conclusion. The experiment confirmed our hypothesis, which is more water results in a shorter rolling distance. The trend line showed a clear negative correlation between water volume and distance. Why? What does this cause? Heavier bottles have more friction and inertia. This makes it harder for them to maintain momentum and roll further. The skills learned from this experiment are real world data collection, data organization and graphing, regression analysis, and slope interpretation, clear communication, and collaborative work. This project helped us link physics and statistics in a simple yet meaningful way. Thank you.